Welcome to Unit 4 Opener number 12. What we have here is a right triangle, I presume. I'm going to go ahead and just draw in a little right angle there because I think that's required in order to do the problem. And we're supposed to find the length of the longest side. Now we have two sides, and as you may have learned previously, in a right triangle, one of the sides is sort of special, and we call it the hypotenuse. The hypotenuse will always be the longest side of the triangle, and you can sort of tell just from looking at it that this is going to be the longest side. And it's the side that is across from the right angle. So if you start inside the right angle and you sort of shoot yourself out of it, you will always hit the hypotenuse. The other two sides we just call the legs. That's one of the legs, and this is the other leg. And there is a very nice rule about right triangles that's been around for a long time. It's called the Pythagorean theorem. And it says that if you take one of the legs and you square it, and you take the length of another one of the legs and you square that, so first leg, second leg, you will always get the length of the hypotenuse squared. Now, instead of writing out the words, a lot of people just write a squared plus b squared equals c squared for the Pythagorean theorem. It's just really, really important that you remember c absolutely positively has to be the hypotenuse. It can't be one of the legs. All right. Well, knowing that, let's do this problem. Find the length of the longest side. So that's the hypotenuse. That's this side, and I'm going to go ahead and put a variable there. I'll just use x. And so I'm going to take one leg squared, so that'll be 60 squared, plus the other leg squared, that'll be 25 squared, and it's supposed to equal the hypotenuse squared, so that'll be x squared. And so now you just sort of work this out. Go ahead and get my calculator out. I guess I can probably handle 60 squared without it, but just to be safe. So that's 3,600 plus 25 squared is 625. I guess I could have handled that one too. And that equals x squared. So then I add these two things together, 3,600 plus 625, and I get 4,225 equals x squared. And so in order to solve for x, I can square root both sides. And let's see, I'm not sure whether or not this is going to come out to a nice whole number or not. Let's see, 4,225 square rooted. It does. It comes out to be 65. Now, if you've watched some of the other videos, and I'm thinking about openers 8, 9, and 10 here, you're thinking to yourself right now, well, Mr. Michelson, you need to put that plus minus in front of the 65 because you square rooted both sides, and that means you could have gotten a positive 65 or a negative 65. And strictly speaking, you're correct. In fact, if we were only looking at that part of the problem from there down, I would agree with you. But the problem is, not the problem, but the reality is that right now we're talking about a triangle, and it doesn't make any sense for a triangle to have a length of negative 65 as one of its sides. So in this case, you really don't have to worry about the positive and the negative. Only the positive answer makes sense in this case, so the answer comes out to be 65. Just be careful when you're doing these problems. In this case, we were looking for the hypotenuse. If the problem looked a little bit different, and if we had a right triangle, maybe the side lengths were even the same. Maybe this was we had, let me make this side a 25 and this side a 60. And you were supposed to find this missing side. Just be careful. In this case, the 60 is the hypotenuse. So the equation you would be setting up would be x squared, because that's a leg, plus 25 squared, because that's a leg, equals 60 squared, because that's the hypotenuse. All right, so just be careful when you're setting up your equation with the Pythagorean theorem. The hypotenuse always is over here on this side squared by itself, and the two legs squared are over on the other side being added together.